Hi, this video is designed to kind of get you started with the test two Excel work and maybe answer some questions. I'm showing right now my test two write-up in the analysis plan. And I thought I'd kind of sketch out how I would at least begin or think about doing this. So one of the things that I know is that there's two parts to this. There's the data summaries, which are like what I would say like required, like you need to kind of do this for every variable, and so there's kind of information here on what to do for those variables. And in the second part is the more open-ended part where we're going to do exploratory data analysis. And I want to make sure that you're clear on what everything in here is in case you need to refresh yourself in the Brightspace page in the content tab. If you come down to class videos and click on that, you'll see there's this exam 2 test 2 class videos. And in here are the videos that cover pretty much everything you need to know how to do in Excel to do these videos. So we have the February 28th class Zoom recording, and that kind of goes over the concepts. That's also in your e-text on the Connect class. You can have all that as well as your class notes. Then we have 3 videos that are more Excel oriented, and they go over how to do a lot of the things in Excel. So I'm not going to repeat stuff that's already in these videos. I'm just giving you sort of a high level structure here. So going back to that analysis plan, it says that we're going to do this for the analysis ready data set and the millennials subset. Will be summarized and reported in an appendix as follows. So what I would recommend, and I think it is sufficient, is to do this for the analysis ready data set and the millennials subset. I don't think you need to also do all this for the millennials females and the millennials male. I think that might become sort of a lot of stuff that we don't need as much. And usually if you have a main data set, so that's our analysis ready data set, we're going to want to do this for that. And if you have a sort of requested or primary subset, and that would be the millennials, we would also want to see how these things change there maybe, and we need to do this for that as well. So I'm just going to go over the structure for the analysis ready data set, and I'll leave it to you to implement it for the millennials. Okay, so the first thing we're going to look at is the numerical racial skill variables that are not binary. And for these, we're going to want to get measures of location, dispersion, and shape, and provide those in some kind of tabular format. And then also, we're going to have some visualizations of what's going on for each one of those variables individually. So this is single variable visualizations. And I thought I'd just show you kind of what I would do. So here is our analysis ready data set. And I brought over the variables definition file. I just put it here because I kind of wanted to have it near me so I could see it easily. You could, of course, just open it from your previous work in Excel, have it just in another file. It's not required to be in here at all. I just put it for my own personal, I don't know, easy reference. Okay, so what I want to do is make sure that I identify what are all my numerical. And I don't know why numerical is showing up in this, in these 3 different, what look like identical spellings, but it must somehow be detecting something different in each inside here. I think maybe one of them has a space in front. I'm not sure what's going on. But anyway, so for all these variables, What I would recommend that we do is we go back over to our full data set and we make copies of just those and put them in their own worksheets. So I went ahead and did that. And so I pulled over those variables that are considered ratio scaled numerical variables, and I put those in here. And then I'm going to need to summarize each one of these. So what I am going to do, or you can do this different if you have a clear, organized, easy to follow alternative method. So I'm fine with you doing your own thing. I actually like that. I just want to make sure it's not all random chaos that's impossible to follow. Okay, so for the numerical, what I did is I'm copying over the variable names, and then I went through my analysis plan. So let me put that over here side by side. Oops. Yeah. Okay, so in here, I just went through and I put, okay, I want the mean, median, mode, the min, the max, the first and third quartile. Then I'm going to have these measures of dispersion. And then I have these shape variables, and I want the count, the sample size. And the count, I don't know if we really need that. We have clean data. We need it for maybe one variable, and for the rest of them, it's going to be exactly the same. So we're not going to get that much out of repeating count for any other variable. It's just a little bit tedious. But in here, you know that I had shown you that if you're working with one variable and you need a quick summary of that variable, you can always go to data and the data analysis tool pack, and then go over here to descriptive statistics and then put in a column of data and get that. So we've done that many times. Unfortunately, this descriptive statistics package does not allow you to put more than one column at a time. It can't, it doesn't seem to be able to interpret if you have more than one column of data. So I played around with it, and I did not get that to work for me. And it's missing some of the stuff that's in our analysis plan. So what I would do is I would go ahead and program this. This is in the same order that the variables are in my numerical worksheet. And I would go ahead and program one of these, like household size, and put in the individual functions, like the average function, the median function, the mode function. I would put that in for each one of these, and then just copy the formula over to the other columns, and it will, because they're in the same order in that worksheet, the formulas will copy over and calculate everything correctly. And of course, you'd want to go through and double check everything. And then if I go back to my analysis plan, it says I'm going to create box plots for any of these variables. So to kind of give me an idea what it looks like. So down below the summary statistics, I've created a space where I'm going to put a box plot for each one of these variables. And then I read in my analysis plan, I remember writing it, that if I see something in a box plot that looks like there's maybe something weird going on in any way, whether we shouldn't have any outliers except for that spending 2021, right? We kind of cleaned the data. And I remember that was the only one we still had outliers for. So other than that, I shouldn't be seeing outliers, but I may see skewed distributions, or I might just be curious. So for anything that I want a little more granular view of the distribution, I'm going to put in some histograms. Okay, then the next thing that I want to talk about in my analysis plan are the summaries for the categorical data. So I have some information in here. And so for that, I'm going to go in and I'm going to, again, I can use my variable definitions. You don't have to pull it in here. You can just look at it from your other, where you have it in your other data wrangling Excel file. But then I'm going to pick the categorical ones. And I might want to see what these numerical binary ones are. I may or may not. They're sort of going to be covered in some sense by the categorical, but I just don't want to forget about them. So I can say okay to that. And then these are the variables that I'm going to use or pull into my categorical list. And I actually don't need zip code, right? We said we are going to not do customer ID, which already I did not grab. I did grab zip code in here by accident. So let's get rid of that. And in here for race, I have the reduced race, which is what we said we were going to do. So I have some categorical variables, and I want to do a frequency table and a relative frequency table for each one of these. So what I recommend you do is that you select all this data. So go from A1 all the way down to the bottom right corner, select this rectangle of data, and then insert a pivot table in a new worksheet. Okay, so what this pivot table is going to do, it's going to give you all these variables here. And what we can do is set up one pivot table at a time, one contingency table at a time, and this just change the variable in it. So I'm going to start by pulling down sex to the rows, and I'm going to pull down sex again, and I'm going to get the count of sex, and I'm going to pull down sex again, and I'm going to get the relative frequency. So hopefully by now this is something you're comfortable doing. And I'm going to make a table by copying this down. And I'll put this table here. Oh, sorry, not like that. My bad. I want to paste only the values. Okay. And then I want to format this table and make it look pretty because it's going to go into my technical report. So I'll let you play around with that. So here is an example where I did this for sex, and I'm just going to change this to sex. It doesn't matter really because we have this, we're just counting how many records we have. So in this example, I formatted this table down here and I created a little pie chart because if I read in here, I want to create if there's only two categories, I'm going to do a pie chart just so I can see how they're related really quickly. Otherwise, I'm going to do a bar chart. I could also do a pie chart. You can, as long as you're clearly visualizing the distribution of the data, you can do a bar chart or a pie chart. Pie charts that have too many wedges begin to be hard, like, I don't know, difficult to read, but that's might just be my personal taste. And I have to follow my analysis plan anyway, which says I'm going to do this. Anyway, so here, I just show you a couple, like you would keep building new pie chart, new frequency tables and relative frequency tables and sort of formatting them and creating things and creating nice charts to show the distribution to go along with that. Okay. So I'll let you work on that. And then, so we need to do that for all those variables. And then for the exploratory data analysis, it says all pairs of numerical variables will be evaluated for the correlation. So this was something that is in one of the videos. I showed how to do this. Trying to remember which it was. It's one of the data visualizations. It's either part 1 or part 2. I don't remember. It might actually be in the summary statistics and correlation actually at the end. Anyway, make sure you know everything that's in those videos. So then for the correlations, I would go back and I would run a correlations and all those numerical data, and I would end up with some kind of grid that would show the correlation, the R value for that correlation coefficient. And then I'm going to do scatter plots with a trend line for any correlations where the absolute value of the correlation is greater than 0.3. And this was a little bit of a typo. Nobody caught it, unfortunately. Could have been some extra points for someone. It should have been the absolute value of that correlation coefficient being greater than 0.3. Now, I think I accidentally put the absolute value on 0.3 originally. Anyway, so anything that looks like there's something greater than a 0.3, I'm going to do a scatter plot with a trend line. Okay, so that's where I left a little note in here to myself that I need to put those in there. And the next thing is I say contingency tables will be created for all pairs of categorical variables. And by the way, what I'm kind of doing right now is the initial kind of description and search within some obvious areas to consider. There's a lot more we can do here, and that is described in these data visualizations, parts 1 and 2, where you can use the stuff that's in here for the exploratory data analysis. I will be looking for at least one example for each different type of thing and intelligent design. You know, I want to see that you're not just randomly doing crazy things that don't mean anything, but you're actually trying to like think about what is in this data and what is it telling us and how can I visualize that or how can I check it? Remember, anything we see in here, we may eventually do more rigorous statistical analysis like hypothesis testing or regression analysis. So what we're looking for right now is to generate hypotheses. And when I say generate hypothesis, I don't mean hypothesis test alone. It could be hypothesis test, but it could be the possibility that there's a relationship between variables that we would maybe more accurately and analyze with regression. So for that, we would just look for correlations. And in the contingency tables, we'd look, you know, if one thing seems to be very related to something else or something looks very different in a group in one value of a category than another. So here's an example of a contingency table. So here it's also using, I actually made a copy of the frequency table worksheet where I had all my categorical variables pulled in. And I made a copy of that to start the contingency tables. And so in this one, I'm just going to look at every pair. So I'm starting with sex and college. Then I'm going to go to sex, zip code that we're ignoring, but sex and satisfaction, sex and channel. So every single one of these, I'm going to go and make all the pairs. So there's a lot of these that need to be built. So the first one for sex and college, I put sex in the rows and college in the columns. And in the count of college, I went ahead and decided to look at this by the percentage of the row total. So I want to see the breakdown within each sex. So I went ahead and selected that. And I know that's the case because I have hundreds at the end of the rows for the grand totals. Now I made a copy of that and format it nicely the way I liked how it looked. I think this is appropriate for a technical report. And then I went ahead and made a bar chart. And I played around with different ones, right? You can play around with different chart designs. So maybe you wanted to do side by side. So that would look more like that. Or you could maybe go to a stacked bar chart. And because we are working with 100%, this one is kind of going up to 120 here instead of going up to 100%. It's not really the better choice once we are doing a relative frequency or contingency table, which is giving us the percentage by row. It might make more sense to go with the one I had, which is the 100% stacked column. So I have that here. And again, you don't have to use this. You can use whichever one you think you like. Okay, as long as it's clear and is portraying the information in a clear way. I formatted this a little. I gave this some, a title. I played around with the font on the bars. So all of that is stuff that you want to get good at so you don't spend tons of time working on it. Okay, now let's say I say, okay, well, I kind of want this the other way around. And this is also in, I believe it's the part 2 of the visualizations video, or it might be in part one, where I say, okay, this is the percentage that each one of these is of female. So whether they went to college, um, whether they did not go to college, and if we just don't know. But I want it maybe the other way around. So I got to come back up to the pivot table and I got to flip this. So I'm going to go over to the count of college value field settings, show value as, and instead of percent of row total, I want this as percentage of column total. So I'll say okay on that. Now notice that my totals below are 100% on the columns. All right, so I'm going to copy this over so I don't lose it. And by the way, I may need to add more space in here when I add in some of the other categorical variables that have more categories. If not, it's going to write on top of this. So you do want to watch out for that. So let me just, first of all, copy this over. And then let me add in a bunch of space. So I'm going to add in some space in here just to give myself a buffer. I don't want to overwrite anything. Of course, if you accidentally do it, you can always undo and then realize you need this. And it stretched out my graph. So I'm going to shrink that back down. I don't need the giant graphs. Make sure your graphs are not so small that they're hard to read or impossible to read, right? You don't want them ginormous either, okay? So this is college by sex. And so let's go in here and I'm going to, basically, I want to copy the top here. And I'm going to copy that here. So I already worked on that. And I'm going to format. I'm going to copy the formatting. So I'm going to right click and choose that little paintbrush icon. And I'm going to come down and select this part. Right, so now it did a nice little formatting for me. And I want to make the bar chart for the breakdown of this by of college, yes or no, and the breakdown of male and female within each of those categories. And you have to be very careful in your interpretation. So you're going to maybe spend a little time really trying to think about what these things mean. So if I put this in here, let's say I put it in like this, a side-by-side bar chart. So this is female and male side by side. Maybe I want to add data labels here. So what this is telling me is of all the people who went to college in this data set, 36.5% were female and 63.5 were male. Now that is not saying, so, and you can get cute here if you want, you know, and I know that maybe you decide that you want the fill for female to be, I don't know, green, and you want the fill for male to be some other color. Maybe you want, you know, go traditional blue, baby blue, something like that. It's really can be deceptive, right? You can say, oh, less women go to college than men, but it's really just in this data set there were more males in the data than females. Another way we can look at this data, right? We can go to chart design, change the chart type, look at the 100% stacked columns. And so we can say, actually, it's roughly the same whether they went to college or not. So let's make sure we put this title correct. So this is sex by college. So if they went to college, yes, no, or unknown, and if they're male or female, so we can see the percentage. What we do see is that proportionally in the ones that did not want to tell us, a higher percentage of the ones that did not want to tell us were female. Okay, so you can see that more clearly in the way this is presented than the way it's presented over here. Okay, so that's just some stuff to think about, generate some ideas in your own head, and then you're going to want to do, and you don't always have to do both versions. You just want to be really clear. You might come back later. You might have a question, come back later and look at and add some. So this is where we are in that exploratory data analysis area. And in that section, recall, we have this whole additional graphs will be provided. And by the way, these bar charts are not specifically stated in my analysis plan. All right, all I'm saying is I'm going to do a contingency table. So really, and maybe in some sense, I should actually just give a contingency table. So let's go back up here, change the count of college, and let's do show value as, and I'm going to say percentage of the grand total. And that will give us a true amount that each specific cell is, right? This is the joint distribution. This is what's called the joint distribution. So it's when, if it's the probability of being female and going to college overall in our data, or the probability of being male and not going to college is 9.63, right? Female and college was 30.48, male and not college is 9.63 overall. So this is an empirical distribution. It's a contingency table stated in percentages. And it gives you like the marginal distribution. So on the end, we can see that females were overall 36.9% of the data, males were 63.1. Those add up to 100 going across the bottom. We get that 83.4% of the customers in this data set went to college, got a college degree. I'm going to just round 15% roughly did not, and around 1.6 did not report. So that is a true contingency table. So let's go ahead and copy that one down, because actually everything else that I've done up until now comes under the not stated specifically in the analysis plan. So let me copy this down. I'm going to copy it down with paste special. Oops, I don't like where that went. I need another space. Let me go with one. So paste special here. And I'm going to copy this formatting down, up, I should say. So I'm going to format this, and I'm going to copy the renaming of college in that part. So I'll put that here. Okay. So now we have, this is truly a empirical distribution. It shows the distribution of each cell, the joint distributions. The conditional distributions is another way to think of the marginal distributions. So if you, sorry, the joint distribution is another way to think of the joint distribution is the conditional distribution. So if you're female, I take that back. These are the conditional distributions. This says if you're female, what's the probability that you went to college given that you're female? So that's 82.6. So down here are the ones that are the conditional probabilities. Okay. So other than that, you want to go ahead perhaps and add another worksheet. And in here, you may rename this as, exploratory data analysis. And maybe you have, not crazy amounts of stuff on one worksheet, although you can put quite a bit, but you can have more than one page, like page 1, page 2, wherever your brain takes you on this exploration and what you find in this data. Now, you want to do some of this also with the Mills. You don't need to do it for the Mills M and the Mills F, okay? I think that might be overkill. We might come back and make just some very targeted visualizations, specifically asking questions that we have already identified. For the Mills, you are basically going to be adding a lot of worksheets. Okay, so that is the general sort of guideline for doing this work in Excel. Okay, let me know if you have any questions or if you get stuck. Otherwise, I wish you happy hunting, happy fishing. Some people call this exploratory data analysis a fishing expedition, because you can find, if you look too hard at, for too long at too many things, you can find things that aren't really relevant. So there is a balance here. Okay, well, have fun.